In this screencast, we'll discuss a Python and PIL implementation of the concepts that we discussed in the previous screencast, edge detection with gradients part 1. So we'll start with the luminosity formula. A viewer sent me a question where I got it from the wiki article about luminosity. If you search on wiki luminosity, you will find it. It's a pretty commonly used formula. It has 3 coefficients and simply multiplies the corresponding red, green, and blue values by those coefficients and sums them up. So translating RGB pixels into gray intensity levels. Then there is this utility that simply checks if C and R are within the bounds of a PIL image object. Then we are in PIL C is X and R is Y, and the top left corner is the 0, 0, 0. Okay, so the first is RGB pix dy that computes the differences in luminosity between the two vertical neighbors, the upper and the lower neighbor of the pivot pixel at C and R. RGB pix dx does the same between the horizontal members of the pivot pixel. So 2 luminosity values. It doesn't really matter which order we go because we're going to be squaring those values, and if there's no difference, we return a small number so that our A tangent 2 function doesn't misbehave. The gradient magnitude is just the Pythagorean theorem. And that's the square of the sum of the squares of the difference in the x direction and the y direction. The theta gradient theta is well, we compute the 2 differences, and then if they are the same, we return a small value, and if they're not the same, we apply this A tangent function and then multiply it by 180 over pi just to convert it into degrees, for no other reason, because in my humble opinion, degrees are much easier to deal with when you analyze and debug vision programs. So this is the utility that we used in the previous screencasts on PIL. On Edge is basically an iterator, a Python generator rather, that yields tuples CR and RGB pixel value. And detect RGB edges is the real workhorse. It takes all these defaults, the function to compute gradient theta, gradient magnitude, the function to compute the luminosity difference in the x direction and in the y direction, the luminosity function, then the default delta value, small value if there's no difference in the luminosity, default theta, which we return if there is no, if the pixel is not in the range. Theta thresh is 360, which means that we accept every theta, but magnitude threshold is 20, which means we do not accept gradients whose magnitude is less than 20. So we establish the generator, and then we gonna iterate over the pixels, RGB pixels. So gpix is the RGB, well, C and R value of the pixel column, and then we compute gradient theta and gradient magnitude and convert them into integers. Okay, and then finally we iterate over the values in theta grad pix, and we accept the thetas so long as they're within 360, which means we accept everything but gradients only greater than or equal to 20, and if there is an edge detected on the pixel, then we set it to 255, otherwise it's black 0. So the edges will be marked with white. So here's a couple of sample inputs and outputs. By the way, the link to the source code will be in the description of this screencast. So the left side of the image is the input image, and the right side of the image is the output image. There also will be, the link will be provided to these images so that you can reproduce these results. So here's a diagonal image. So this is the input image, and this is the edge detected with the code, the Python code. This is the wedge, triangular wedge. So this is the input, and this is the output. This is an interesting image. It's a nutrition table. It's part of the one of the research projects that I'm currently working on. And so this is the edges detected on these image. Okay, so this is an interesting ornament. So the left side is the input, the right is the output. So, and it's another interesting ornament with the input and the output on the left side and the right side respectively.